Hey, hi guys, so today we are going to discuss another one of the important question which is being asked by Amazon, Facebook and a lot of big companies, okay, Google, like that kind of company, and it is asked thousands of times, multiple times they have asked this particular question. So let's understand this particular question. So that look like very much straightforward question, but if you find it, but you need to find an optimal algorithm. That is the main important. What do you mean by optimal algorithm? You need to find an algorithm which takes less time complexity. Okay, so that is our main intention, don't forget that. Okay, so let us understand that this particular question and try to solve this particular question. Before going for the question, so if you are new to my channel, just try to subscribe this particular channel. If you will get a lot of good contents like this particular questions and all, and just press the bell icon also inside my channel so that you will get a notification whenever I am making a new video. Okay, so that's all about it. So let's understand this particular question. So given an array, okay, so and a number x. So there are two things is given. One is input is two things. One is given an array and second thing is given an x. Okay, given x. So what we are finding, find all pair of numbers whose sum is x. That means we will find pair of numbers from this particular array whose sum is x. Whose sum is x, that is 9 in this particular example. So you just tell me what are the pair of numbers available in this particular array whose sum is 9. Can you tell me? So I can see, so by 5 and 4, 5 plus 4 equal to 9, right? So that means, so the solution of this particular program should be written 5 and 4. So that means this is the pair of number which sum is 9. Okay, so whether if I ask whether any two other numbers exist whose pair sum is 9, no, because 2 plus 5 is not 9, 5 plus 8 is not 9, 4 plus all these things if you calculate, okay, so then the sum is not 9. So then the answer of this particular question is given a array and a x, and try to find out all pair of numbers, such numbers whose sum is 9. Okay, so that is the question. So what I want, so I will be writing actually 3 algorithms with a different time complexity. We will be discussing each 1 2 3, okay, 3 algorithm. But before going to see this particular full videos, I just want you to just pause for a 1 minute and think about the solution. Write in your copy and just try to match which algorithm you have written. Okay, whether you have written the best algorithm, whether you have written the middle algorithm or the worst algorithm, so that you will try to understand how you can improve yourself. Okay, so just pause this particular video for 1 minute and come back after writing your algorithm, and let us I will just continue. So let us continue here with algorithm 1. Okay, so let us continue with algorithm 1. Okay, just think, I think you have already tried, so I think, so the easiest method is just try to add each numbers and try to see whether this is giving 9 or not. So that is the easiest method, right? Try to add 2 with 5, check if it is giving 9, 2 with 8, 2 with 4, then 2 with 3, 2 with 9, then it is not 9, then just we are done. Then 5, start with 5, 5 with 8, 5 with 4, 5 with 3. So whenever you are adding 5 with 4, then you will get a solution, then print that particular solution 5 and 4, then 5 with, but still you will continue because you are finding all pair of numbers, right? You are finding all pair of such kind of numbers. Then 5 with 9, so you are not getting, so then you will start with 8, 8 with 4, 8 with 3, 8 with 9, so you will continue in this way and you are going to get the all pair of numbers. So let us try to see how can you write this particular algorithm. So I am just writing the algorithm. So what I will do, I will start from this number and I will try to add other numbers. Okay, I will start with second number, then I will add this number. So if you have basic knowledge of for loop, so I will write two for loops then. For I equal to 0 to n, okay, and or I can go to this particular point because it is going to be n minus 1. So I am writing the algorithm, I am not writing the code, right? You can just write the code also, that is nothing. For I equal to 0, I less than equal to n minus 1, I plus plus, so you can do that. Second step is, this is a nested for loop for j equal to, for j equal to I plus 1, because whenever I am here, I am just trying to add this one, that means j will be varying from this to this. Okay, so whenever I will be here, then whenever you take 5, then j is going to vary this one, and it will add and try to give the answer. That's why I'm writing for j equal to I plus 1 to n Okay, do what we need to do. I need to check if the sum is x. If the sum is x, then we need to return that particular, or we need to print that particular, pair. So if I write in this way, if a of I plus a of j equal to x, then just print this. Print what? A of I comma, I am writing the algorithm comma a of j. Okay, so this is the structure. Okay, this is the structure of my algorithm. That is the fast algorithm. Okay, so but the question is, what is the time complexity of this particular algorithm? It is going to print each and every pair of this particular number, all the number whose sum is x, but the time complexity of this, let's analyze. Okay, I think it is pretty much straightforward if you have some basic knowledge of time complexity. So this is going to be, since this is going to be n, okay, so number of computation, this is going to be n, and this is going to be taking some constant time. Okay, so this is going to be, so this is a inside for loop, right? So this is going to be n into n, so which equal to big O of n square. Okay, so the time complexity of algorithm 1 is big O of n square. Okay, so this is the time complexity. But now the next question arises, can I improve this? Can I write a little bit more efficient algorithm which will perform better than this order of n square? Okay, so can I write some algorithm? So I am just erasing this one, you can take a look. But can I write an algorithm which is going to take little bit less time compared to this order of n square? Then answer is yes, we can do that. So let us go for algorithm 2. Okay, this was algorithm 1. Okay, we got it in order of n square. So let us go for algorithm 2. So algorithm 2, actually whenever you are writing this particular program, if you are going for Amazon and that, they will give you some hints. So that's where I am giving one hints. Make a use of sorting actually. Okay, can you use sorting something and you can improve this particular time complexity? Okay, pause this particular video. If you have already done sorting, then that's okay, or else pause this video, just try for a sorting, just sort and try to write an algorithm. Okay, so second algorithm is based on sorting. Okay, so what you will do, okay, sort the numbers in decreasing order. Okay, I'm just writing sort the numbers, that's okay. Second point is, this is algorithm 2, sort the numbers. Okay, so once you let's see, actually before going to writing the algorithm, let's understand how it will behave. So I will first sort the numbers. So 2 3 4 5 8 9. Now just think about this way. Okay, so this is the sorting. Okay, so now tell me, I need to find out all sum whose x is 9, right? So that is what I need to find out. Now just think, how can you find out this particular solution? Okay, how can you find out the solution? Just start with, I will take two pointers here and there. Okay, so just try to understand, this is very important. So if I add this 2 plus 9, so it is becoming 11, but I need how much? 9, right? So I need the sum should be 11, right? Yes, sorry, sum should be 9, but whenever I am adding this to this, so I am getting 11. That means a greater number. Just think whether, if I will keep on increasing this pointer, if I suppose, I am giving an example, suppose I will keep on increasing this number, whether I will able to find a number 9, obviously not, because this is going to be increasing order, because we have already sorted. So if I will go to here 3 plus 9, then it is going to be another greater number 12, right? So that's why don't, in this particular, this is suppose left, this is right. So if this number is greater, okay, that means this sum is greater, then decrease the right pointer. Okay, that means if the greater, so that is the algorithm. Okay, if sum is, okay, greater than x, so that is the algorithm. We'll write, you need to do right equal to right minus 1. Okay, so that's what you need to do, because let us understand the algorithm first. We'll write, so we need to point this one to here. Okay, so now let us see whether 2 and 8, so now 2 and 8, so it is 10, so now I am getting 10. Okay, so whether it is 9, no, I am checking it is not 9. So if it is not 9, it is greater than 9, yes. So then which pointer I need to decrease? The right pointer, right? So now I will remove this right pointer, I will decrease to here. Now let us look at now the game has changed. Now let us see. Now if I will add a of left and a of right, that means 2 plus 5, what is it is going to be? It is going to be 7. 7 is not greater than 9, rather it is less than 9, right? So what I will do, I will not, this time I am going to increase the left pointer, right? This is very important. Increase the left pointer. Okay, try to understand the logic actually behind this. Okay, increase the left pointer. So now I will try to add, I'll just continue this particular process until unless I get a hit. Okay, so 3 plus 5, it is 8, again it is less than this, so then I am going to increase this. Okay, so this is my left pointer, it's going to be increased. Okay, so now 4 plus 5, now we got a hit, then and we don't have a element, that means we don't have more element. 4 plus 5, yes, it is 9, this is matching. So now the algorithm terminates and we don't have more elements to add. Okay, so that is the algorithm of this particular second algorithm. So we'll write down the algorithm, okay, and then analyze the time complexity. So in order to write the algorithm, so first step is the sort the numbers. Okay, first that is first thing. Second thing, what we are telling, we are taking a 2 pointers, one is a left, one is a right. So these are index. Pointer means just a index, right? You know, we are using an array. So left equal to 0, I can say left equal to 0, right equal to size minus 1, size of a minus 1. Okay, that means this is 0 and this is 0, 1, 2, 3, 4, 5. This is 5, right? That means size is 6, so that's why it is size minus 1. Okay, third step is you need to start traversing from this side and that side, but you need to continue till which point? That means whenever left and right is very much closer, that means left is less than right. So this is very important. While left is less than right, okay, left is less than right. Okay, so if left is less than, because left is increasing that way, right is coming that way. Whenever left is less than right, then we will continue. Okay, so what will be the condition here? Okay, there will be only if condition, there is nothing much. Okay, if a of left plus a of right equal to x, let me erase it. Okay, if both are giving the solution, if equal to x, then what I need to do, I need to print it. Okay, print a left comma a right. I am writing algorithm, that's why I am not bothered about much syntax, you can see actually. So this is right. Okay, a right are one pair whose sum is x. You can just write anything, just a message here, printing. So if the sum is x, okay, else if their sum is not x, just write how many condition I need to write. Else if a of left plus a of right, I could have taken one actually variable to store this, but that's okay, is suppose less than x. Okay, suppose less than x. Okay, so yeah, a of left for less than x. Less than x means, so this is a smaller quantity, right? So I will take the example. Suppose, think about this situation. Okay, that means no, this situation has come, right? So 2 is here, suppose 5 was here. Yeah, this was the situation, this was left, this was right. Okay, when we decreased, initially we decreased right 2 times, then so a of 2 plus 5, which is less than 9, because x is, this is 7x. In this situation, what you were doing, you were increasing the left, that means left equal to left plus 1. Okay, else means this is going to be greater. If you remember the first situation, this situation, so 2 plus 9 equal to 11, so which is greater, then we were just reducing the right. So right equal to right minus 1. I hope you are able to see. Yeah, right minus 1. Okay, so now if after this completion, so this is going to print all these things. Okay, so now this is the algorithm for this particular problem, or this is the algorithm 2 for this particular problem. Now tell me what is the time complexity of this algorithm. The algorithm 1 that we have discussed, that is the order of n square. And the question is, what is the time complexity of this particular algorithm? Whether it is giving a better solution, let's analyze this. So if you know, if you have the basic idea of sorting, so sorting takes, it can take order of n square, you know, but if you are using efficient way of sorting, so it will take order of n log n. So that is order of n log n. So this is the assignment operation, so that's okay. So that is taking actually order of 1 time or big of 1 time. Okay, this is a while loop. Okay, so this is precisely will go maximum what can happen. So this is going to sort from left to right, complete thing, right? So this is going to be order of n. If you will think about means it is, if it is optimally divided, then it is n by 2. If it is starting from left to right, so then it is n. So it will be n. And these are all some constant, right? So then the total time complexity is nothing but something like that, right? So something like this. So which is nothing but big of n log n, if you know the basic big O. So I hope you understand. So the algorithm 2, that means this algorithm, whatever we have designed now, is giving a better time complexity, if you can say. It was taking order of n square, you know, right? Order of n square is a little bit worst compared to order of n log n. So that means we were able to write an second algorithm, okay, algorithm 2, I am just erasing this, algorithm 2, okay, so which is taking big of n log n, okay, this is algorithm 2, okay. So now we have written 2 algorithms, okay. Now, but the question is, can I further, then they will ask you whether you can further improve the time complexity. Can you do using something differently which will take little bit less time. More less time means less time, I can say actually, yeah, which will take little bit less time, okay. Can you do that? Okay, so let us understand how can we do that, okay. But that solution is having a constraint. It is not exactly, it will find the solution but having a constraint, okay. This algorithm 3 we are going to discuss. I'm just giving a hints, okay. Use concept of map, okay, use the concept of map and just try to see whether you are able to find the solution, okay. Just try to see, okay, just try to see, just 1 second guys, yeah, just use the concept of map, okay. So algorithm 3, okay, so have you tried map? Okay, so what you need to do, okay, what you need to do, okay, you need to take a map. Just think about the behavior of this particular problem actually. So then you will get a constant, okay. That means if you think, if I just take a map, suppose I am taking a map, so I am giving an example, just think about this particular. So I will take it from 0 to suppose 9, okay, 0 to 9 something, 9, yeah, right. So if suppose 2 is coming, 0 1 2, okay, let me write it down properly maybe, so that you will get a clarity, okay. So what I am trying to do, so suppose this is 0 1 2 3 4 5 6 7 8 9, okay. Suppose 2 is coming, okay. So what I will check, I'm using a map. I'm just going to, suppose everything is 0, so I'm going to check x is 9, right, whether 9 minus 2 element is present. Just try to understand whether 9 minus 2, that means x minus a of I is present in this particular map. So now suppose if I'll think no element is present, right, so that means 2, you can add this one 2, okay, 2 directly you can actually add it here. 2 is, you are just doing a 1 initially, suppose everybody is 0, okay, everybody is 0, so I am making this one as 1. Now 5 is coming, means I will check whether 9 minus 5 element, what I am trying to check, if 5 is coming, I am just checking whether 4 is present or not. So that's what I am checking, okay. I am directly going to 4th index and checking whether there is a 0 or 1, there is a 0, so that's why 4 is not present, so that's why I will make this one 1, okay. So now what I will do, I will go for 8. Now whether 9 minus 1 is how much? This is 9 minus 8 is 1. Whether in one index, whether an element is present? No. If one element is present, then this 8 plus 1 is going to be 9, right? So that's why we are searching for this way. This is a intelligent procedure, okay? So this is going to be 1 now. No, not this one actually. 8 is going to be 1, okay? So now 4 is coming. Now 4 is coming. Now let us see carefully. So this is very important. So here we will get a match, right? So let us see. So now 4 is coming. Whenever 4 is coming, I am checking whether 9 minus 5 element, okay, so sorry, 9 minus 4, which equal to 5, whether this particular index element is present. Just go to the fifth index. Sorry, I think whenever I was inserting 5, I should have inserted here only, right? 5 means you should be inserting there, okay. Yeah, so whenever you just check whether 9 minus, just revise this one, yeah, because 2 means we are inserting at 2 position, 5 means we will insert at 5 position, 8 means we are going to insert at 8 position. But checking time, I am just going to x minus a of I, okay. So I am checking 9 minus 4, that is fifth element is already present. Yes, so that means it is a match. So if you will see, there is a relation, that means sum of this particular thing is nothing but 9. So that's what we are checking, okay. So that's what we are checking, okay. So this is 4 plus 5 which equal to 9. So that's why I am checking 9 minus 4 which equal to 5 is already present, means it's conjugative element I am trying to find. Conjugative means the sum of this particular two number is 9, right. So I am trying to find whether already 5 is present. 5 is already present. Then I will make that 4 and 5 is a pair. I will continue because I need to find out. I will continue the same process, but I am not going to find out any match, and I will update this particular 4 as 1, okay. And I will continue this particular process until I complete all the element. You got it? So this is the algorithm. So this algorithm, if you will talk about the time complexity, it is going, what it is doing, it is just traversing a array, and it is directly, it is not traversing here because it is checking the index. So it is directly checking a of 5 because a of 5, right. So that's why this particular algorithm is going to take order of n time, okay, order of n time, because it is only a single traversal. There is nothing much. One for loop will able to do this particular, complete this particular task. So that is a single for loop, okay. So that's why this is a order of n algorithm, but the constraint is, so this particular maximum you should know, okay. So this should not be like infinity, okay, or a very large number, so that this array size will be grow, because if you will see this map we are taking based on the maximum element present in this particular array, okay. So that's why this is one of the taking a little bit space complexity more, but yeah, time complexity point of view, it is going to take order of n time. So let me just write down this algorithm quickly so that you will able to understand, okay. So I hope you got it, but still I will just write it down, okay. So let me write it down, okay. Algorithm 3, okay. So this is very important. So we are just taking, first of all, we are taking a map, okay. So this is a map we taken, right, 0 to 9. So map equal to, and we are initializing everything with 0, okay, and we are initializing with 0, okay. So this is the first step, we are initializing for map with 0. Then I will traverse this array. What I am doing, I am traversing this array for I equal to 1 to n minus 1 or 0 to n minus 1. I will just search whether that's corresponding other element is present or not. That means for I equal to 0 to n, okay. So what I am doing to do, what I am trying to do, okay. So this is very important. If, okay, m of x minus, sorry, m of, this is very important, I think you know, x minus a of I is present, okay, a of I, okay. If this is present, okay, if this is present, if this, or else you can say this, okay, initially it is 0, so if this or equal to 1, you can say equal to 1, okay, then print the pair, you got it, right, what I am trying to say. 9 minus, suppose 5 is coming, 5 will be inserted at 5th location, so this is going to be 1. Whenever 4 is coming, that means 9 minus 4, which is equal to 5th. It is trying to find out its companion actually. 4, I am searching for 5. Whether 5 is present? Yes, 5 is present. Then definitely this is a pair. Okay, print the pair of element whose sum is 9 or x. Okay, so this is the if. Okay, else what we are doing, if it is the sum is not we are not finding that companion, we are just inserting that particular into the array, into the map actually. So else, or else you can set this else. Okay, set m of fi equal to we are just doing 1. Okay, okay. So print means you are printing which one actually? Yeah, you can say, yeah, print the pair element, means this a of I, actually a of I comma and m of x minus a of I. Okay, okay, x minus a of I actually, not m of x minus a of I. Okay, so that is okay. So what I am trying to do, so I'll just repeat for 1 minute. Okay, so I am just trying to read this particular array and just trying to see whether that's companion is exist in this particular array or not. So I will go for 2. 2 means its companion is how much? 9 minus 2 means it is 7. 7 is present? No, it is not present. Then 2 will be inserted in 2 second index, 0 1 2, just index, insert it. Okay, for 5 there is 4 is already not present, so that's why 5 will be inserted at the 5th location. 8 is their companion is 1 is not present, so that's why 8 is going to insert at 8th location. Okay, so that's how it is going to continue. Okay, so for I equal to 1 to 0, sorry 0 to n, so we are just trying to see if the companion exists, so then print it, or else set this to 1. Okay, so what is the time complexity? So this is just an assignment, so this is a big of n. Okay, and this is this conditional, so this is going to be big of n, only one for loop is there, so this is going to be big of n. So we found another algorithm 3, okay, algorithm 3 whose time complexity is big of n. Okay, but it is having a little bit space complexity challenge, you can understand, because we are taking a extra map with having maximum, so that is one thing we need to consider. But in this particular method we have already discussed 3 algorithms and along with their time complexity. I hope you guys enjoyed this particular video. Just subscribe this particular video if you are interested to get such type of videos more for, and just comment what was your first thought, whether you have written algorithm 1 or algorithm 2, algorithm 3, because I asked you to write it in the copy, right? Just write down your comment. I just want to know for curiosity, what was your algorithm you have written by yourself, algorithm 1, algorithm 2 or algorithm 3. Okay, that was the approach, and yeah, thank you and stay connected. Thank you.